This is the Unit 11 Algebra 1 credit recovery. So on number 1 it says to factor completely. So our steps to do that is to take a look at our GPS. G stands for greatest common factor. We always need to check for that first. Is there a number or a variable that I can pull out of each of these terms? On number 1 there is not, so I write none. Next I checked my product. It's my first times my last term. So x squared times negative 32 gives me negative 32x squared. And your sum is always that middle term, so this is negative 4x. So because I didn't need to pull out a GCF, I can go ahead and draw my box and fill out my first and my last box. The first box will always be that first term x squared. Last box will be my last term, negative 32. And from here, I need to do my factor table. So again, my sum was equal to negative 4. My product was equal to negative 32. So now I need to find multiples that multiply to negative 32. I always start off with 1, and here we can get 32. And right now I'm ignoring my negative signs, and I'm going to add this back in. But 1 times 32 gives me 32. To get the rest of those numbers, we can take a look at our calculator. If you go to y equals, all you have to do is write your product, 32, divided by x, and then check your table for multiples. So 1 times what would give me 32? 32. 2 times what? 16. 3 doesn't work because it doesn't give me a whole number. 4 times 8 would work. And then 8 times 4, but since we already had those two numbers, 4 and 8, I can stop right there. So taking a look at my table, we had 1 and 32, 2, 16, 4, and 8. Since my product is negative, that means that my signs need to be different. I have a bigger column right here and a smaller column of numbers. So my signs for both of those columns need to be different. Your bigger column always matches the sign of your sum. Here we see that our sum is negative, so my bigger column all needs to be negative. Which one of these adds up to negative 4? That gives me 4 and negative 8. So I'm going to plug them in here, and it doesn't matter which box has what number. Now taking a look at this, we're seeing what can I pull out of my top row? X squared and 4x. What would evenly divide into both? I can pull out an x. We see that x times x gives me x squared. X times what gives me 4x? That would be a positive 4. X times what would give me negative 8x? That would be negative 8. Let's double check. Does negative 8 times 4 give me negative 32? Yes, it does. So here our factors end up being x plus 4, x minus 8. Taking a look at number 2, we are going to look for our GPS first, using that to guide us. Here is our greatest common factor I can pull out of each of these terms. It ends up being 3x. So I need to rewrite it out. I have 3x times, this ends up being x squared plus 8x plus 7. So we pulled out a 3x for our greatest common factor. Our product is always our first times our last term, 7x squared. Our sum is just our middle term, 8x. So taking a look at my box, I can fill out my first box based off of my expression inside the parentheses. My first term was x squared. My last term was 7. Now writing our sum, that was equal to 8. Our product was equal to 7. 1 times what would give me 7? That's just 7. And since 7 is a prime number, there aren't any other numbers that multiply together. So from here, let's check. Does 1 plus 7 give me 8? Yes, it does. So we're going to plug them in and add our x to them. Taking a look at the top row, x times x gives me x squared. X times positive 7 gives me positive 7x. X times 1 gives me 1x, and 1 times 7 does give me 7. So here we end up with x plus 7 and x plus 1, but don't forget that greatest common factor we pulled out at the very beginning. We need to include that in front right here as well. 3x times all of that. Number 3, taking a look at our GPS again. Is there a greatest common factor I can pull out of each of these terms? No, there isn't, so we're going to write none. Our product is the first times the last, which is negative 42x squared. Our sum is 11x. Drawing our box, our first term is x squared. Our last term was negative 42. My sum was 11. My product was negative 42. When I multiply numbers to get me to 42, we have 1 and 42, 2 and 21, 3 and 14, and then 6 and 7. Since I have a negative product, that means my signs are going to be different. My bigger column needs to match the sign of my sum. Since my sum is positive, all of these are going to be positive, but we need different signs, so that means my smaller column will be negative. Here we see that negative 3 and 14 add up to 11. So I'm going to plug them in. Doesn't matter where they go. And I'm adding an x to them. What can I pull out of x squared and negative 3x? It ends up being x. We know x times x gives me x squared. X times negative 3 gives me negative 3x. X times 14 gives me 14x. And if I multiply 14 times negative 3, I do end up with negative 42. So my factors here end up being x minus 3, x plus 14. Number 4. Number 4, using my GPS to guide me, it looks like I do have a greatest common factor. It ends up being 6. So I'm going to divide each of these by 6. We end up with 6 times x squared minus 9x minus 13. So our g was 6. Our product is the first times the last, negative 13x squared. My sum is that middle term, negative 9x. So here, if I draw my box, we have x squared in that first box and negative 13 in that second box. Your sum is equal to negative 9. Product is equal to negative 13. So 1 times what would give me 13? 13, since it's a prime number, we know that I don't have any other multiples. Negative product means different signs. My bigger column matches the sign of my sum, so this should be negative 13. Does this add up to negative 9, 1, and negative 13? No, they don't. So that means that this part ends up being not factorable. So here, my solution just ends up being 6 times x squared minus 9x minus 13. Number 5, it says find the expression that represents x squared minus 25 in factored form. This one ends up being a difference of two squares, a dots problem, or DOS, difference of squares. Here, since I have two terms, it's a binomial, and if there's a minus sign in between, I'm going to check to see if I can use the rules for dots. Can we take the square root of the first term? Yes, we can. Square root of x squared is x. Can we take the square root of the second term? The square root of 25 ends up being 5. So now I can write this as x and 5, and one term is positive, and one factor is negative. And that's the answer to number 5. So number 6 is very similar here, except this one is not a dots problem. This one actually is not similar. But this one we can still solve using our GPS. So on this one, is there a greatest common factor I can pull out? No, there's not. Your product is the first times the last. We get negative 35x squared. Your sum is always that middle term, negative 2x. Using our box, we have x squared in our first box, negative 35 in our last box. Your sum is negative 2. Your product is negative 35. We get 1 times 35 gives me 35, and 5 times 7 gives me 35. Negative products means different signs. Bigger column matches the sign of my sum, so we get these as our negatives. And here we get 5 and negative 7 add up to negative 2. So here it doesn't matter where I put them, but I do need to add my x. I can pull out an x from x squared and 5x. X times x gives me x squared. X times 5 gives me 5x. X times negative 7 gives me negative 7x. Negative 7 times 5 does give me negative 35. So here my expression ends up being x plus 5 times x minus 7. Number 7, this one is similar to number 5. So this one is also a dots problem. I can take the square root of x squared, and that gives me x. I can take the square root of 144, and that gives me 12. So here we get x 12, x 12. One factor needs to be positive, one needs to be negative, and that is it. Number 8, although it has some variables in it and numbers, this one actually also ends up being a dots problem. If I take the square root of 81a squared, I end up with 9a, because the square root of 81 is 9 and the square root of a squared is a. If I take the square root of 144b squared, square root of 144 is 12, square root of b squared is just b. So I can write these out, 9a and 12b. 9a, 12b, one needs to be positive and one needs to be negative. Number 9, this one is actually a perfect square trinomial. What I mean by that is if I take my last term and take the square root of that, the square root of 100 gives me 10. Okay, what if I take the middle term, negative 20, and divide that by 2? What number do I get? Negative 10. Regardless of whether or not they're positive or negative numbers, are these the same numbers? Yes, these both have 10. So that means that I can write this as a factor squared. And here I just take whatever sign my middle term is. So here I end up with x and 10, and that middle sign was negative. So it's x minus 10, all of that squared. Number 10, taking a look at this one. I always need to check for a greatest common factor first, and it looks like I do have a greatest common factor here. I can divide each of these by 3. When I rewrite it out, I get x squared plus 10x plus 25. Let's check to see if this one is also a perfect square trinomial. Looking at the stuff on the inside, if I take the square root of my last term, I get 5. If I take my middle term and divide it by 2, I also get 5. So this one is a perfect square trinomial. It ends up being x 5 squared, and my middle term was plus, so it's x plus 5, all of that squared. But make sure we remember our greatest common factor that we pulled out at the beginning. We need to include that in our answer as well. Number 11. Number 11 is not a dots or a perfect square trinomial, so we need to solve it using our GPS. This one, there is not a greatest common factor. My product ends up being 2x squared times 15, which gives me 30x squared. My sum is just that middle term, 11x. I can draw my box. My first term was 2x squared. My last term was 15. Sum was 11. Product was 30. So here, 1 times 30 gives me 30. 2 times 15. 3 times 10. Any others? This one just ends up with 5 and 6. Okay, so from there, positive product means same sign. They both need to be positive. Here, 5 and 6 add up to 11. So I'm going to plug them in. It doesn't matter which one goes where. And I need to add my x's. X can be pulled out of 2x squared and 5x. X times 2x gives me 2x squared. X times 5 gives me 5x. 2x times a positive 3 gives me 6x. And 3 times 5, does that give me 15? Yes, it does. So this one, my factors end up being 2x plus 5, x plus 3.